It has been a journey throughout. I think all the industry who have been associated with space, maybe defense also, which I do not know very well, have greatly benefited by the association in terms of upskilling there, in terms of the quality, the processes, world-class products generation, etc. I think this has been a journey in the last so many years. Now we have demanded yet another level. For human rating, we have introduced a new approach called the human rating certification process, which includes process intensification, higher levels of verification, higher levels of control from manufacturer side, from designer side, and everybody testing. I think this journey has been going through for aircraft industry very well in this country, but it has never been put into rocket industry, which is a new thing. So we are now grappling with the challenge of doing certification. Semilac has been doing it for defense, air force, but for us, there is nobody else. So we have created our own mechanism how to do it ourselves. Ultimately, when a human being flies on it, somebody should certify it. I think that it has required confidence to have the flight. But it's going to be different than the aircraft, I must tell you. The aircraft, the unknown fellow is sitting in there, but here is a known fellow who knows the risk of it is sitting there. So there is a difference between these two, and he is competent enough to handle a critical situation, whereas a typical person flying in a commercial airliner is not prepared to handle it. So there is a big difference between human rating rocket and human rating an aircraft. But that challenges is something that we are managing now. We are hopeful that we will be able to do the proper certification and make the industry understand the demand that we have today. I think many of the top industry who are helping us, I must tell you, the HAL, the Larsen & Toubro, the Godrej, and then there are many others, Lakshmi Machine Tools, who are all here. They all understood this, and they are upgrading their internal capability in terms of processes, stores control, material control, quality, cleanliness. No, there are many elements of it, which they are upgrading themselves to reach that level.
So when you said about the quality and then we have to create our own standard, I can understand that. I was in a similar situation when we have to put our air independent propulsion into a submarine. Always Frenchies said, no, you cannot put it unless otherwise we certify. And we go to them, they will not certify, they'll find fault in us all the time. It was keep going on. So finally, I met Kakotkar, who was a secretary then, Secretary of Atomic Energy, and then we formed a team with ISRO, DRDO, and Atomic Energy. And he said, India, within these three agencies, if we cannot find a solution, nobody else can find. So let us go ahead. So I'm sure we have to take it sometime on our stride and go along. With the Atmanirbhar in vogue, and many Indian industries are helping in our missions nowadays, what do you think is the share of space for the Indian industries?
See, the scale of activity in terms of economics, it has not been large, I must admit, in terms of the overall turnover of the business, when you look at it. Our goal is that it has to be increased to almost 10 times in the coming few years. If it has to happen, many things have to happen. It has all the time a closed economy, closed door activity, spearheaded by ISRO. And industries continue to remain as suppliers of components or sub-assemblies, never upgraded themselves beyond a point to reach the system integrators, system designers, other than for some ground equipments and systems. This is the major change we want to make here. But unfortunately, the situation is quite different than what you see in US. The US, the industries have been creator of those knowledge, whereas in India, industries has not been the creator of the knowledge to start with. They were manufacturers. But then now we have to upskill them, to enable them, handhold them to handle it. That is precisely what we are trying to do, to hand over the technologies that we have today with the form of satellites, rockets, hand it over to the industries, take them responsible for it, manufacture it, operate it, launch it, make business out of it. It's very easily said and done, but it's a huge task because it involves skilling, it involves knowledge transfer over a period of time. But we have to handle it. Especially in the rockets, it is much more challenging, but in satellites, it's much more easier. So I believe this challenge is being taken up by industries, understand the business ecosystem, and if you limit within the markets in India, it is not going to grow. We have said that it has to be a global market. How to create global market, how to create alliances, how to create potential for sales for all of the products that you do. It's again another big question mark. But then we have to go through this journey and transfer the production, operation of all the systems of what we do in space to the industries. And the National Space Agency should concentrate on R&D, development a new ecosystem, and transfer progressively to industry. This is precisely the way in which the economy can be increased. The the utility of space system within this country is still not fully explored. This is another big area. The utility can be in a big manner, especially for the digital economy that is coming up, digital connectivity, the high data rate demand, the image intelligence that are required, the weather and other related information that are required to be given to service sectors, agriculture, natural resources planning. No, there are many areas where there is a business opportunity. Slowly I am seeing companies like startups building up this capability to create revenues out of it. We are also trying to offer our entire data set came out of the satellite with the industries for them to make value-added products and services. We want to make sure our satellites and rocket cycle, even our ground facilities, to be at the disposal of the industries for them to make use of it, to value add on it. So all these are the things which we have to do to create a vibrant space economy. So this transition is happening through various mechanisms like the in-space, the NSIL coming more into the manufacturing responsibility taking over, and ISRO working on more inspirational and long drawn such inspirational missions as well as scientific pursuits.
Very good. What you said is very important. That is, the knowledge is not transferring from the company to to the institutions and government, whereas we have generated already and we need to give. In the top level, we understand and we also agree with the management and agree with the sort of government of the day and would like to give. But when it comes to the down level, I myself felt plenty of scientists will be present in giving everything away. So this constant churning between the industry will come and complain. We will agree at the top level, but the tail will not move exactly the interest of the head. It's a big problem for both of us, of course. Very good. Of course, we'll do it. Coming to the other area, you talked about the man mission. I'm extremely happy and proud. Likewise, today, if you look at the robots, they are able to mimic you and me as much as possible, including the expressions. The recent China's exposition shows that what all the robots can do. In case you can replace someday, I mean, we start as a sort of initiative, robot with some sort of an AI, and then which is not having any fatigue problem associated with a human being, and if it can replace, one day will ISRO go for a mission, I mean robo mission.
See, we are going to go the very first mission itself as a robo mission. The unmanned mission which we are going to do next year will carry a robot. Our Vyomitra will be there on board to do minimum key operations, speech interaction, visual clue giving, etc. But your question is slightly different, I understand. Your question is related to don't send human beings, only replace human beings by robo forever. I think that is precisely the goal of the humanity. Yeah. There is no need for human beings need not go. Absolutely. If you can develop a robot which is competent enough to understand, yeah. For that there are new technologies getting developed, like cognitive technologies. Interconnecting a robot with a human being which is sitting in the ground through sensory perceptions. If you can get the feel of what the robot gets through a sensory perception of a human being, there is no human being need to go. And only the dexterity by which you operate an equipment. That also has to become better. Today the dexterity levels are not of that class. A human being can handle tiny objects and then do chemical composition, additive manufacturing, some machine operations. That will improve over a period of time. The automation and industry will make it to the dexterity processes much better. The only difference is cognitive, because the cognitive capabilities have to improve substantially in terms of vision, hearing, feel, sensor, smell. All of this have to get integrated to get the whole feeling of the situation. I think again another bigger element is human beings are not like machines. They have a capability which is beyond machines, and that emotions and the humanity aspect of it, they understand deeper than a machine can understand. That's why human cannot be totally eliminated, but we can substantially reduce.
I'm coming to the specific point connected with the Tamil Nadu now. In Kulasegarapatnam, you are trying to make a spaceport which is second to whatever you have. I understand that you are requiring about 2,350 acres of land, and as of now, you have made about 83% is over. What this second port will do, in addition to probably declustering your number of launch demands, will there be anything more to Kulasegarapatnam?
See, my whole purpose of this new launch station is not to replace Sririgota or decluster. It is to create an alternate launch site. Today in India, we have only one launch site, which is Satish Dhawan Space Center. We must have a geographically placed another center. Second element is we must support new emerging launch actors, especially the small satellite building and small rocket building. They must have a more exclusive, more free place to operate on their own facilities. This is the second objective. Third objective is that around any new launch site, an industry cluster should come up which will support such manufacturing and launching, both small rockets as well as small satellites. So if you look at it in that sense, I believe the location of Kollywood is apt for it. Because small satellite launch vehicles towards south launch, this is an ideal place which gives you higher payload capability. And we are also working around a lower turnaround time per launch, so that per year at least 20-30 launches should take place from here in a manner that will support the large scale and increase in production of satellites and launches. And I believe around that an industry cluster also should come in the due course of time.
I know that there are industries coming up building rockets as well as satellites. Are they going to help the space ecosystem? What is your advice? Should they have to focus more on rocket building, satellite building? Because you said only 30% is these two activity probably, or mostly on the data analytics, which is the beneficial to humankind as well as beneficial to the industries.
See, ultimately I must tell you, rockets are launched for putting satellites. Satellites are meant for some applications. And if applications don't deliver the product, none of these are useful. So the primary use of any space mission is applications. It's not launching by itself. So we must focus on applications, and unless applications and its benefits accrue and create value, there will be no drivers for the higher end. So let us understand it very, very well. For example, if you look at I'll tell you the communication revolution, the mobile phones. You understood, we lived in an age where we are importing and living with that. Now we understand we can't. We must create it here. And it has to not only create the mobile phones, but the downstream tower networks, the transmission equipment, the network elements, the hardwares, all of this should come. And that the money is there, not in mobile phones alone. So if you really understand the economy of this, you will understand that much of the money is in the applications and delivery of applications ultimately to the user. You focus there, then everything else will drive. We will get the better rocket, we will get a better satellite built only then. Otherwise, it will continue to remain as a very less number production. The demand in the market is something that has to increase, and we have to create it by a conscious action.
Commercial aircraft or a civil aircraft industry, they started using the commercial components. They don't even go for a aerospace component. But then in the case of satellite, I know that it's the highest class, but I find most of the industries wherever I visited, some of the startups, they don't seem to be having that conscious feeling of the quality or whatever it is. What is your advice? Is it okay to all of them? Because anyway, even if it becomes a non-usable, it's going to be one more debris
Not that
that's
way.
there.
See, I think the thought process are slightly changing. Reason is simple. For space, we have been traditionally taking components which are of heritage items. That means they are not the latest. They are few years behind the technology. Because the reliability comes in because of longer usage of any electronic device. This has been the culture. I think this is slowly changing now. And we are trying to build now mechanism by which the latest of commercial devices can be used in satellites. And the approach is that they are now very reliable today, not like the earlier times. And you can build redundancies on using a low-cost devices better than a high-end item without redundancy. So this approach is helping in new actors to build very fast turnaround, high operating, low volume, low power devices with high reliability. I think we must go in that direction.
I've been cautioned twice by my colleague that we are overshooting the time. If it is acceptable to you and if it is acceptable to the audience, I'll ask a few more questions. Yes? Okay. Yes, with you?
Yeah, I'm okay.
See, 3D printing has come in a big way, and people say even the rocket engine itself is 3D printed. What do you think is going to be the value for 3D printing or worth of 3D printing in the industry?
3D printing is a very upcoming technology, and I very believe that it will revolutionize everything. But it has to be very cautiously detected. One of the important challenges is to characterize 3D printing processes, especially the metallurgy, residual stress, the product-to-product variability, which is natural for the current manufacturing. There is a continuity. Sampling concepts work in conventional manufacturing, whereas sampling concepts don't work in additive manufacturing in an effective manner. This is the biggest challenge today. And for rocket and aircraft area, it has a great potential. I think we must work on it. And in ISRO, we have created an R&D specific focus on to understand this mechanics of additive manufacturing and make products out of it. We have to push our limits to it, and it will have a great transformational power. But today, there are a lot of threats, there are challenges. Many things are not going all right. We tried our 3D printed engines. It has its own challenges. It's not working the way conventional engines work. It has inefficiencies, performance issues. But we will overcome all of that.
You started the year with a bang of XPOSat. What is the utility of that?
XPOSat is an X-ray polarimetric satellite looking at black holes. I think you know black holes are the ones which you don't give any information. That's why they are black. But to get information from them, we are using another technique called the polarimetry of the emitted X-rays when a black hole is interacting with some other body. For example, if it eats into another star, material will flow from that star to this black hole, and it will generate X-ray radiation. And if your X-ray can be polarized and polarimetrically analyzed, then you can understand the quantification of material that is flowing, the speed of the black hole, the size of the black hole, the emissions of the black hole, its life, its creation. Many things can be understood. So we have created two instruments on board, one in low energy and another in high energy X-ray polarimetry. And this studies black holes, spinning black holes, binary pairs we call it them, and how stars ultimately die. I think this physics is something that we want to study for the whole of the scientific community.
You have already industries like L&T and some more company I know in the development of rockets. Do you have a plan to index similar way some more industries? If so, when?
Plenty. I think the number of industries which ISRO is dealing with is almost 400. I have a list of them. 150 of them are doing major work. Some of them are suppliers, and many of them are converting products to indigenous products. I must tell you, some of the large-scale indigenization that happened in the last so many years is really, great. For example, when I was a young engineer, I never used to use a nut bolt which is Indian. Now I don't even import not even a single nut or bolt from outside. It's manufactured in India. Just talk about that. Cables, connectors, relays, devices, passives, all sort of alloys. I think we are slowly moving to a direction of the ability of the industries is now showing up. The high-end products I am not describing. There are plenty. They are capable of doing it in optics, sensors, fiber optics, and devices, integrated circuits, designs which are happening. I think the contribution of industry has been substantially over a period increasing. But now the greater collaboration between the West is happening. With that access to higher end technologies, like the government is initiating the ISET program and various others, we will have greater access to those knowledge.
The more and more players in the game, satellites are going to become a lot of debris also. Is there any program existing to reduce them or take them or clear them or clean them is existing within the country or outside the country?
Say, bringing a satellite back is equally difficult than putting it there, because so much of energy has gone to it. Think of a 1-ton object moving at 12 km per second speed. It's huge energy. To kill that energy and bring back, you need equal amount of energy to be given. So for that, there are a lot of initiatives. At least I am aware of 3-4 companies who are working on deorbiting programs. There are guidelines getting created globally to do that. So this direction is moving in terms of global push for it.
Okay.
I think it's a time up for us.
I think so. So we'll end it up. He's not allowing us to go. Yeah. Space tourism, I'm sure it will become some time, and you will also push that point. Any other question from the, yeah, please. Okay,
Only two questions. Thank you. Hi sir, I'm Samir from the US India Business Council. We were at the launch of ISET. So just wanted to understand from you, what is scope for international collaboration, and how do we look at FDI in the new space policy? Are there any rules coming out sometime soon? Can you please answer this question?
The FDI policies with the government now, they are yet to clear it and announce it. It will happen soon. It will be the DPIIT. We are very, very positive, very pragmatic views are taken in the FDA policy, allowing it as much as possible. The government should be allowing it in automatic route. But of course, this sector has its own challenges of ownership and other related issues that you have recently come up. So from that point of view, there will be certain amount of oversight need to be there in FDA. In terms of ISET, I believe that the access to high-end technology is something very crucial for India. We try to make sure that in US also that if you give access to the high-end technology, it is beneficial not to India, it's beneficial to you as well. In terms of your ability to re-engineer products at a lower cost in India is something going to be good for US. This is something that we tell them. So give us that access to the high-end devices and technologies that are coming up, at least to Indian private industries, so that they can value add it and deliver it back to the customers there. This is something which we are trying, and we also get benefited because it generates employment and jobs, opportunities and R&D capability in India. It vice versa helps in US to reduce the development effort and time. We said that we gave examples how it is happening, even with space. Thank you.
This is the last question.
Warm regards to the speakers. My name is Ujjwal Sonkar, and I have been in research in security affairs. I studied space warfare from Lomonosov Moscow State University. I recently transitioned my career as a startup, so we are working into quantum communication. And we have NDA signed with Tata Advanced Systems Limited. They are helping us get the first experiment by March. And we have also submitted some proposals to HAL, and they have shortlisted it, but still there's a lot of more procedure which is slowly going forward. We would like to propose ISRO that we wish to make a quantum communication satellite with a dedicated payload for laser-based quantum entanglement. And this is a project of national importance, and we need some more people on board, talents like you, and all.
On it. We also developed payloads to handle quantum entanglement, single photon devices. It's already there. We are going to launch one satellite next year middle to demonstrate QKD functionality through an optical communication link. But this is only a demonstration. But an operational QKD satellite to encrypt the terrestrial networks is something that we are working on. I think we will be happy to discuss on it. Thank you.
Yes, I understand there is a fire chat discussion between us. And I was wondering in the beginning, where is the fire? But finally, I realized that you are the fire. Thank you very much.
Thank you so much, sir. Thank you so much. It's really a pleasure to have an eminent speaker like Dr. Christopher and now I may request Mr. Arun Sundar, the IAS officer, and Mr. Krishnamurthy, IAS officer, and I may request Dr. Christopher to Thank you so much, sir. We request you to be